So in chapter 7.1, we're going to be going over the Cartesian coordinate system and linear equations in two variables. So starting with points and ordered pairs, this is going to be a way we can essentially visualize numbers, is we can plot them as points on a graph. So one way we can do this is using the Cartesian coordinate system, or it's also called the rectangular coordinate system. It's essentially just the xy plane. We have a x-axis, which is the horizontal axis, and a vertical axis, which is called the y-axis. So all this is two number lines that are intersecting each other perpendicularly. So here it is right below it. We have this horizontal axis is the x, the vertical is the y, and they meet right here in the middle where they're both 0. So you can see as the x's, as we go more to the right, the x's get larger. As we go to the left, they get more negative. And as we go up, the y's get positive. And as we go down, the y's get more negative. And it keeps on going from negative infinity to positive infinity for both of them. So essentially, this is used to see how an x input affects a y output value. Okay, so each point in this rectangular coordinate system is going to correspond to an ordered pair of real numbers. So an ordered pair of real numbers is going to be x. It's going to be denoted x comma y. So the x is first. So x comma y is an ordered pair of real numbers. So the x coordinate, which is the first coordinate in the ordered pair, is the horizontal distance from the origin, which is horizontal distance from the middle. And the y coordinate is going to represent the vertical distance from the origin, and it's the second component in the ordered pair. And the origin, like we mentioned, is the middle of the xy plane, the middle of this rectangular coordinate system. It's the coordinate 0, 0, where the axes intersect. Okay, so when we have these two lines intersecting each other, 4 quadrants are naturally going to occur. Quad meaning 4. So we have this quadrant here, this one here, this one here, and this one here. So the one on the top right, we call this one quadrant 1. I'm going to use Roman numerals here. So quadrant 1, the x values are positive, and so are the y values. So positive x and positive y. Quadrant 2 is actually over here, so we go counterclockwise. Quadrant 2 has negative x values and positive y values. And quadrant 3 is down here, and we have negative x values and negative y values. And lastly, quadrant 4 is right here. We have positive x values and negative y values. Okay, so those are the 4 quadrants, and essentially just every combination of positive and negative x and y that we can have. Okay, so let's do an example where we're plotting these points. So we have this is just the notation. This means point A is the coordinate negative 3, 5. So negative 3, 5 is going to be, we have to remember that the ordered pair is x, y. So x is first, y is second. So negative 3, 5, that's going to be 3 to the left in the negative direction and up 5. So that's going to put us right here, and that's point A. Point B is 2, negative 4. So to the right 2 and down 4. It's point B. Point C is 6, 0. That's going to be 6 to the right and then 0 units up or down. So that's actually going to be on the x-axis. So it had a vertical distance of 0, meaning it's on the x-axis. Point D, negative 4, negative 3. To the left, negative 4, down 3. It's point D. Point E is 0, 4. So there's no horizontal distance in the x direction, but we go up 4. That's E. Lastly, point F is 0, 0. That is the origin. Okay, so just make sure you are good with plotting any of these points. Okay, next for solutions to equations. So a solution of an equation in two variables, which we'll just be using x and y, is going to be an ordered pair of real numbers, such that when the x-coordinate is substituted in for the x, and the y-coordinate is substituted for the y, we get a true statement. So for example, let's show that the ordered pair 3, 2 is a solution to 2x plus 3y equals 12. Okay, so the point that we're given, the ordered pair, is x, y. So what we have to do is, using this equation, we have to plug in 3 into x and 2 into y. So we're going to see if this works. So plugging in a 3 into x and a 2 into y, we're going to see if that equals 12. So simplifying this, we get 6 plus 6 equals 12, and we get 12 equals 12. So since we got a true statement, 12 equals 12, we know that that ordered pair is a solution. Okay, so now let's show that the ordered pair -2, -7 is not a solution to 2x plus 3y equals 12. So once again, let's plug in x, y here. So we're going to be using the same equation, 2x plus 3y equals 12. And plugging in a -2 into x and a -7 into y, and then simplifying the left-hand side, that's -4 minus 21 equals 12. That gives us -25 equals 12, which obviously is not true, so I just put a little x like that, saying that that's not true. So since we did not get a true statement, this ordered pair is not a solution. So now for the next thing, we can actually complete ordered pairs if we're given an equation and one of the coordinates in the ordered pair. So what we have to do is substitute the number for the one variable into the linear equation and solve for the missing variable. Solve for the missing coordinate. So let's complete each ordered pair for the equation y equals 4x plus 5. So we have 7 comma something. So we're looking for the y coordinate here, and x equals 7. So we know that x equals 7, and we're looking for y. So what we're going to do is we're going to use this equation and plug in x equals 7. So we're going to get 4 times 7 plus 5. That's going to be 28 plus 5, so we get 33. So that means completing the ordered pair, it's going to give us the ordered pair 7, 33. Okay, next we have blank, -3. So that this time we have y equals -3. So using the equation again, we're going to plug in -3 into y and solve for x. So this is going to be -3 equals 4x plus 5. So hopefully we remember how to solve linear equations. We have to subtract 5 on both sides. That'll give us -8 equals 4x. Divide both sides by 4, we get x equals -2. So this is going to be the coordinate -2, -3. Okay, and then for C here we have 0, blank. So once again, now we have x. We know that x equals 0 and we're looking for y. So using the same formula, y equals 4x plus 5. And plugging in x equals 0, we get 4 times 0 plus 5. 4 times 0 is 0, so 0 plus 5 is 5. So this gives us the ordered pair 0, 5. Okay, so extending this definition a little bit further here, we can use it to complete a table of values. So this is pretty normal way of seeing ordered pairs as a table of values. So let's do this example, complete the table of values for each question, write the result as ordered pairs. So we're pretty much doing the same thing here. So we have x minus 2y equals 8, and we have these different, I'm going to erase these in a second, but we have these different values. We have 2 values of x, 2 values of y, where we want to find the other variable, and then write it as an xy coordinate. So let's start with x equals 2. So starting with x equals 2, we're going to plug that into the equation and solve for its y coordinate. So it's going to be 2 minus 2y equals 8. We can subtract 2 on both sides and get negative 2y equals 6. Divide both sides by negative 2, we get y equals negative 3. So that's going to be the y coordinate for x equals 2. So as an xy ordered pair, that's going to be 2, negative 3. And next, let's plug in x equals 10. So plugging in x equals 10 into this equation, it's going to be 10 minus 2y equals 8. Subtract 10 on both sides, we get negative 2y equals negative 2. Divide both sides by negative 2, we get y equals 1. So that's going to be the y coordinate for x equals 10. And we write that as an xy ordered pair, 10, 1. And now for the plugging in for the y coordinates. We have y equals 0. So plugging in a 0 into this equation, that's x minus 2 times 0. X minus 0 equals 8, so just x equals 8. So that's the x coordinate, and that's the ordered pair, 8, 0. And lastly, for the last one here, we get for y equals negative 2. We plug that in, x minus 2y equals 8. We plug in a negative 2 into y, and we evaluate that. That's going to give us x plus 4 equals 8. Subtract 4 on both sides, we get x equals negative 4. So that's going to be the x coordinate here, and the ordered pair is negative 4, negative 2 for those values. Okay, so pretty much same concept that we already did, but we're just creating a table of kind of these randomly chosen x and y values. Last one here for x equals 5. So this one's a little bit different, right? We're given all these y values and we're trying to find their x coordinates so we can create their ordered pair. The equation is x equals 5. There is no y to plug into, so this is actually very easy. X is always equal to 5. So no matter what y is, x will always equal 5. So all of these are going to be 5. So these ordered pairs are 5, negative 2, 5, 3, and 5, 6. So the same thing would happen if it was y equals 4, say, all of the y values would equal 4. Okay, so it's completely independent on what the other variable is. Okay, so that's it for this section.